And this semester, our goal was to try some new cases and then make more case study. Yeah, unfortunately, there's some problems on the middle, but yeah, here's our case study.
So we're gonna start with my case. I was wanting to look at specific street canyons across the cities, like across the United States, based on their geometries and their climate mainly, to kind of see how that affect the street canyon geometries affected the microclimates that are in between those buildings for like pedestrians and like residents. And so like the cities I want to look at were Atlanta, New York, Chicago, Seattle, San Francisco. I only got to one. So I was looking at New York City because of there's some vegetations on this strip that I was looking at. The geometries were kind of simple, but also similar. And then it was also a like, narrow street. So this is the strip of geometry that I use. I grabbed from OpenStreetMap. And I simplified the geometry down for to go through 83D. And so when I was running the simulations, it was solved for the vegetation regions, but then right after that, we found that it crashed when it was going through the building regions. The geometry log crashed, but our Gmesh, which is how we mesh the geometry, to go through the simulation, it seemed fine, but so we were thinking that during the remeshing, during the process, something may have gone wrong. So this is what I was doing lately, fixing the geometries, making revisions.
Mm-hmm.
I also ran it last night, but can you wipe to the last slide? There's a file that's supposed to be ran, the face Aguilar merit log, and again, it didn't show up. So I'm assuming that the simulation, I'm predicting that simulation will crash again, but I'll see that.
Last night,
Yeah.
I have also, pushed some changes to the repo last night.
Oh, really?
Outer Plus, right?
Updates? Yeah.
Yeah, of course.
Oh, okay.
Like 11 PM.
But this is, yeah, they've been on the version work that you had, right? You're on an older version that we had tested it for the template, it had worked just for this.
Yeah.
Yeah.
Ah,
So this is
still
unrelated.
different
Yeah.
problem. Okay.
Yeah.
Yes, and for my case study, I focused on the urban mobility in Tokyo. All the buildings, it's basically like over 160 tall, so like it's quite tall. And I got these like 3D modeling data from the government process 3D website, and I basically converted it into the file available on the Rhino from the GMO files. So here's the geometry I got. This is the original data. As you can see, there's so many like gaps and then some like cracks, which would be a problem. So that's the one on the right left down is the one I simplified. And for the meshing method, first I tried Turtle mesh, but as you can see, like mesh is not quite clean enough. And then like it got some, like a geometry problem very early stage in the simulation. So after I checked some geometry inspection. So first I did is like use some check geometry component on the template. It's not like that much detail, but it still checks like if it's close, like too close or not. And also like all the geometry, of course, has to sit on the same g-axis coordinate. And then at the last, I just run like a check mesh on the terminal, and then that's how I figured out like how that tiny edges like having a little weird corner was the problem, and I fixed them. So yeah, and then this is the Gmesh part. Gmesh is the one Marcelo has been used for his own thesis. I also use them. While installing them, there was some problem. It basically didn't like run and it timed out always. We tried a bunch of the ways, any like safety issues, anything. But the problem was just like a unit system synchronization. Like on the Rhino side, export default is millimeters, but sometimes Rhino models are often meters. So my geometry was extremely huge, and then it just basically made it to run out. So yeah, that's how it works.
So this fixed it?
Yeah, it's
Is there a way we can automate this? That like, is there a check that we can do that this is set up
Of
for?
course.
Yeah.
Rhino unit matters.
No, I understand that, but in Gmesh,
Like checking the geometry, you mean, or?
no, this scaling.
Oh, I need to
Okay.
check, but this side is already fixed. So once you just change it, works right now.
So I'm just saying, there should be a warning that's displayed for the user, right? If it's not the
Okay.
case, so we should look into this.
And then, yeah, and then with this G mesh, as you can see, like that mesh is much more cleaner compared with, oh, okay, he's saying it fixes up. Yeah, and then, yeah, so this is the G mesh, and then I realigned with my Tokyo OK 60 case. And there's one problem of the V factor genlock, which was just about the total number of the course faces was over the maximum. So I just needed to change the maximum limit to, and then I run again. But somehow while testing bunch like a same geometry, I had to remesh, like I remeshed one time. And even though it's the same geometry, there's some like a sort of difference in the meshes, and then which led to the simulation fail sometime. So I went with the one of the cases that worked. And yeah, here's a test run. So as you can see, it worked, but the time step was just only an hour because it was a test run. So after this test run, I tried on with the actual time setting, which was because it was for like a room morphology, especially temperature purpose. I set it to the summer and then to warm up the simulation from 4 a.m. to about 2 p.m. And this is the point, like at least the auto press was not fully working, so I had to manually run. And as a result, it ran, but it seemed that result seems quite not right.
Mhm.
And especially like, if you see it down, like most of the areas are quite blue. And I don't think that's how it's supposed to be. So possible reason could be either because I manually ran, I might miss any runs while running it, or also this is the part where Marcelo has been helping me, but we had to turn off the normalization part because it was not like a we just couldn't make it work on the manually, so that could be the reason that result might worked wrong. Yeah.
Okay, so moving on to my case study. My case study was based in Mumbai, and I was interested in like what are the different factors that impact the urban heat island. So like things like geometry, the vegetation, and like the orientation of the buildings. And I wanted to experiment more in the residential area. So yeah. So like we mentioned, the outdoor plus wasn't really working for me, and Ilfra wanted me to experiment more with Fluid X3D. But a limitation to this is that it only allows for wind simulation. So yeah, so then I started with simple geometry, and I got this from OSM buildings, and I had to make sure that they all laid on a flat ground and that the heights were accurate, which I got from Google Earth. And I was also able to find a weather file that was like directly where the buildings are actually located. And then so down, okay, can you go like yeah, so on the bottom are like some of the results, and then go to the next one. Yeah, so I actually wanted to experiment more with the vegetation, but the meshing for the vegetation component doesn't work just yet, so I had to move on from that. Okay. But yeah, this is just some of the results from the simulation, for just a simple geometry. Yeah, and then I moved on to more complex geometry, but this caused an issue with overlapping buildings. And even for this case, this is a lot more spread out than how Mumbai usually is. Like Mumbai's characteristic like geometry is that the buildings are really compact together. So even like with that, it would cause a lot of issues with overlapping buildings. So you'd either have to manually delete them or like move them so that the simulation doesn't crash. And then also it had a different weather file, so like the red arrow is where the buildings are actually located, but there's only one in another coastal region, so I just picked another coastal region to hopefully match them. And yeah, so I wanted to see how like the wind differs based on the heights of the buildings, but when creating the vertical plane, the points weren't being created. And we tried a different method and that worked the first time it ran, but then when trying to move that plane to like a better location to understand how it interacted with the buildings more, those points weren't being created, it just stayed on the original vertical plane, even though there wasn't even a plane there anymore. So I'm not sure what happened with that, but there were new updates to the non-animated version and that works, and I was able to make multiple vertical planes on that, but it still wasn't working on the animated version. But yeah, this is just like the results of the horizontal plane. I'm not exactly sure how accurate this is because this is a coastal region, so I was expecting the wind velocities to be a lot higher than it actually is. But I'm not really a wind expert, but I was just expecting it to be faster. And then this is the results from the one vertical plane that worked. And you can see here, like as you go up, the wind velocities are higher, but I was still expecting on the horizontal plane that it would be faster than it actually is showing.
Actually, we missed the atmospheric boundary layer in the vertical plane. The degradation of the, wind speeds or the gradient of wind speed with different heights, from ground level to the highest levels, it should increase. It was all red, might be a problem, I don't know. There should be some grades. But even if we have the, wind speeds, we need the other parameters like temperature, humidity, right? To have a working version that compete with the other microclimate repo.
Is this, first of all, is this the end?
Yeah.
Okay, yeah. First of all, yeah, thank you. I appreciate your work. Just want to acknowledge that I know you tried hard. It's, these tools are, of course, in active development. And we purposely give you some tools that are the newer ones, right? We have tools that work really well, but we need help with the newer ones. So these ones are a little bit buggy, which is what you have experienced. Yeah, we understand that. So, the fact that some of these didn't work, it will not be affecting your grade or anything. We're aware that this is work in progress. Yeah, can I maybe hear from your perspective? There are some roadblocks with these workflows, and some of them you overcame and some of them you didn't. Do you feel like can we bring this to a state where it's usable with like more checks and more work? Because sometimes, right, like you showed that geometry was an issue. Do you feel like we can have like almost like a warning so you don't have to do this manually, right? Do you feel this is possible to do, that we can display? If you have a geometry, you put it in, it displays, look, please fix the geometry. We think it's not going to work for you. So we can reduce the amount of iteration that somebody has to go through.
Like especially for like the eyes part where it's fixing such a small gaps in between, those are the things like that needs to be for sure removed, and I think it's just very easy to learn.
Also, I'll think of like a new component or plugin to, simplify the geometry for simulation purposes. This is my, one of the most desired, objective.
Yeah.
It's very important. Always we are losing time to simplifying geometry to make it ready for simulation purposes, to make it watertight. There are some kind of Rhino comments like shrink wrap, but it's kind of, crashes the geometry. The sharp edges begins to more, curvular ones. So it is not working as expected. If he done such a, a thing, it will be awesome for the, researcher community.
So I can, we work with ETH on this, and they did the solver, and they have no plugin like this. They literally go to the text file and they change values by hand. They showed us plots and results for a Hong Kong case study that they've done, where it's very sloped, lots of trees, lots of skyscrapers, and it worked fine. And they have these really nice results. So I can promise you that the solver can do it. It's just always the mesh that goes in. So this whole process of downloading OpenStreetMap, which is very bad geometry, and then fixing it by hand and then not being able to maybe do it the right way, that's what makes it crash. It's not that the solver is broken or anything. It is definitely able to do it. We just somehow need to find a way to fix the pipeline and then, start a simulation that has the right assumptions and the right geometry. And then it will work for sure.
That's what I was about to say, that I think we're having those issues with the mesh. And you remember you did like try to do things with like the Rhino meshes, right? And you found those in error, so that you went to Gmesh, but Gmesh still errors quite a bit. So I'm wondering if the Hong Kong study, like how they did their meshing and how they used like the solver, maybe we can replicate that. Because yeah, our workflow right now is a lot of just finding errors in the mesh and then
That's
trying to
always
fix
that.
them, and then there are more errors.
They are using BlockMesh and SnapX Mesh, right? Coming from the native open form.
Yeah, but I mean, we're now basically the ETH is waiting for us to make this open source. I think they're very willing to share some of the case studies with us. Just right now, we're going through the process of making it open to everyone, and as soon as it's open, they kind of basically agreed to share some case studies. So is somebody trying to come in? Okay, we need to leave. But yeah, so we're in the process, but thank you for hanging in there. We really appreciate your work on this.